Hello everyone, I'm excited to bring you today's video where we will explore how to fine-tune models and use function calling to build a fully capable conversational chatbot. This chatbot will be equipped to provide precise answers in Arabic, and you can easily adapt this approach to any other languages. We will focus on domain-specific dataset in medicine and law. First, we will fine-tune two smaller LLaMA 3.2 models, 3 billion models, on these datasets to create specialized question answering models for each topic. Then, we will integrate them as a tool within a larger LLaMA 3.2 model, 19 billion model. The final result, an advanced Arabic-speaking chatbot that will provide in-depth answers related to medicine and law. So without further ado, let's jump in and see what we can accomplish with this powerful approach. So let's get started. Welcome again. So in this tutorial, we will have more resources than usual. We will have 3 notebooks. The first one is related to the dataset creation. The second notebook is related to fine-tuning large language models, 3 billion large language models using Ansloth library. The third one, and I guess the most interesting one, related to the AI agent creation, which is a conversational chatbot with function calling. We will be using the large language models that we have fine-tuned as tools for this AI agent. So without further ado, let's start with the first part, which is dataset creation. So our source dataset is the MMMLU dataset provided by OpenAI. It's open source dataset. You can find it on Hugging Face. The dataset is represented as a quiz dataset. We can see that we have question and 4 options. Only one option is right, and the answer is represented at the name of the column containing the right options. So what we are going to do is to keep only a question and the golden answer. I know this approach, it's not the best approach to create question answering dataset because some of the questions are asking to select the best option, or you can tell from the question it's a quiz question, but it will do the job for us. What we need to do is to first install datasets and pandas on the free Google Colab notebook. Then we import the dataset from OpenAI. As you can see here, we have a lot of subjects. For us to create the first dataset, we will be interested by the professional law and jurisprudence, those 2 subjects, to create our first dataset for Arabic law dataset, containing 1642 rows of data, and we will be mapping the correct answer by its value. So at the end, we will be having question and the reply, the golden answer from the quiz. Following this same process, we will be creating the medicine dataset, but this time with more subjects, because not all the subjects have the same number of rows. So even with more subjects, we ended up with only 810 rows. So after creating this dataset, we can see a sample of it here, and at the end we will push it to the Hugging Face repository. You can find it on my Hugging Face repository, the Arabic Law Instruct and the Arabic Medicine Instruct. Or if you want, you can reuse this notebook to create your own dataset, maybe with different language or different subjects. So once we have our data, we can move to the next part, which is fine-tuning the large language models. So this step right here, I talk about it more in details in my previous videos, but we will go through all the steps once again for another model, which is the LLaMA 3.2 3 billion, and we will be fine-tuning it twice, once on the law dataset and once again on the medicine dataset. So all you have to do is to install the Ansloth library and to choose the model. So as you can see, they have a lot of 4 bits model, so 4-bit models, because we are using the quantized model, we cannot import the complete version of the model. So let's say it's 4-bit precision. The parameters are not like on complete precision, they are all quantized on 4 bits. And once we have selected the model that we want, we can upload it. So here in this code snippet, we are adding the LoRa adapters, so we only need to update 1 to 10% of all parameters, only the low rank adapters, let's say. For the data preparation, we are going to use the alpaca prompt. which is like a predefined prompt for each input and output for the model. So it contains a system message, a predefined instruction for our use case. The input will be the question and the response will be the reply. So after we train the model on this alpaca prompt, when we are going to do the inference, we are going to keep the same thing and we will stop at the response and we will let the model complete the sentence. It's a sentence completion task for the model. It will be like question answering. The model, once it's fine-tuned, it will take the same style of this alpaca prompt and it will not be conversational anymore. So with that being said, for each row of data from the dataset, we will have something like this: the system message, instruction, input and output, and the end of token ID. So once we have the dataset prepared, we can move to the next step, which is training the model or fine-tuning the model. We will be using the Hugging Face TRL's SFT trainer. I mentioned some key concepts here if you want to look deeper. And here in this code snippet, we have all the arguments we need for fine-tuning. One specific argument I want to talk about, which is the max step. Here it's 410. So either you use this max step argument or you can use the number train epochs. Okay, so you need to know how many steps for one epoch. So here 410, it will represent 2 epochs. So to know that, you need to have an idea about the total number of samples in your data and the number of batches. And from that, you can get the number of max steps that will represent one epoch. So one epoch means that the model during the fine-tuning will go through all your data. It will not keep anything out. Here, as I said, I'm using 410 max steps, which is equal to 2 epochs. We start the fine-tuning using trainer.train, and we have all the steps. Once it's finished, we can save the LoRa adapters on Hugging Face. So if you go to my Hugging Face repository, you will find for each model the GGUF version and the LoRa version. So the LoRa, it's the low rank adapters. It's not the complete model, it's only the adapters. So this is the answer from the base model without fine-tuning, which is the LLaMA 3.23 billion instruct 4 bits. I said ما هي أعراض مرض السكري, it's in Arabic, and the answer is something like mentioning a bunch of like symptoms without anything in special. Okay, so now we import the LoRa adapters that we fine-tuned and we ask the same question, and the answer, it's more concise. It's not very clear, but زيادة معدل إنتاج السكر في الدم. So I asked about what are the symptoms of diabetes, and the response here says that it's the increasing of the average of the production of the glucose in the blood. I think it's more acceptable. It's not accurate, but it's more acceptable. The next step is to save the model as the GGUF version, which is to save it on different quantization methods. If you go to my Hugging Face repository, you will find the GGUF. If you open it, you can find the 4 bits and the 16-bit. So if you don't want to fine-tune the model, you want to jump directly to the third notebook, you can import the model from here and use it directly without fine-tuning it. Okay, so with that being said, we can right now move directly to the third part, which is the AI agent. In this final part, we will be creating conversational chatbot with function calling. This notebook contains 4 steps. The first one is importing the models, then prepare the tools list, creating a basic conversational chatbot, and then integrating the tools. So let's start with the first part, which is importing the models. First, we need to install Ansloth, import fast language model from Ansloth, specify the names of the models from our Hugging Face. We are going to import the LoRa model, and then we use fast language model .pretrained and we precise the name of the model we want and if it's in 4 bits or not. Since the base model that we have fine-tuned is already on 4 bits, we need to put this in true. And like that, we can import the 2 models, the medicine one, and with the same code, the low model. Okay, moving on to the second part, which is preparing the tools list. This one, it's a little bit tricky. We need to keep the alpaca prompt the same. In this code snippet, I created a function named parse response. It will get which is between the response and the end of token ID. I created also 2 functions, one for the medicine answers and one for the low answers. Both functions works the same. They will take a question, the alpaca prompt, the model name, and the tokenizer. And when testing them, for example, the get low answer, when we test it with a low question, for example, ما هو الفرق بين القانون المدني والقانون الجنائي, you will get the response clear without the complete alpaca prompt and without the special token. Then we need to predefine the tools that our large language model will use after. For each tool, we need to create a function, the name of it, a description, for example, provides medical information and answers to health-related queries, and for the second one, provide legal information and answers to law-related queries. Also, you need to specify the input for each function. So, for example, this function will have question, which is a required parameter or property, the type of it, and the description of it. Okay, so let's keep that aside for a moment, and let's start by creating a basic conversational chatbot. For that, I'm using Grok, which is cloud provider. So this is not sponsored by Grok Cloud or anything. I just found that this cloud provider is very good for developers. It provides good API keys for different open source models with good limits, let's say. Let me show you here under the rate limits. Not under the rate limits, sorry. Under the API keys, no, settings, limits, yeah. So you can find that for each model you have 13 requests per minute, and for the requests per day, most of them are on 14,000, and the tokens per minute is, let's say, around 7,000. So it will be more than enough for development and personal projects. Okay. Also, if you want more, I suggest that you visit this website. It's an amazing website for benchmarking large language models, artificialanalysis.ai. So you can benchmark different large language models against each others. Also, they are showing a lot of information and insights about the cloud providers like Grok, Together AI, and Fireworks. And you can choose, for example, if you want to move your personal project to production, you can see here and compare which one is better for you in terms of pricing and also in terms of output speed. For example, we can see here that the Grok is the third one in terms of output speed for LLaMA 3.1 instruct 70 billion. Going back to this, so now we are going to use Grok to create a conversational chatbot. So first we start by initializing an empty history list, and whenever we ask a question or receive an answer, we append this to the history as this. Like if it's a question from us, it will be the role user, and if it's an answer from the large language model, it will be the role assistant. So let's see how it works. So first let's say hello. Okay, let's ask simple questions. Who am I? That's not simple questions, I guess. Okay, so my name is and I'm testing LLMs. Okay, the assistant, nice to meet you, Hamza. I'm glad to have a part of your LLM testing process. Okay, so if I ask him what's my name, your name is Hamza. What am I doing? You told me earlier that you are testing LLMs. So the model now is a conversational model. It's not just question answering. It will have like trace of all the history of the conversations, and based on that it will provide you with the correct answer. Okay, so let's move now to the next step. Which is integrating the tools. So how does this work? In this picture we can see that your application will ask the OpenAI, in our case here the Grok Cloud, and the third-party application are the functions that we have created for inferencing the large language models, the 3 billion large language models related to the medicine and law. So first you ask the conversational chatbot. The conversational chatbot will decide if it needs a function call to answer your question or not. So in case it needs a function call, it will go back to your application and say we need more information from the tool, and it will give you the name of the tool to use. Your application will call the tool, get the answer from the tool. In our case, we will give the question to our fine-tuned models and get the answer from them, send it back again to the large language model, and the large language model will give us an enriched response. So that's how it works behind the scenes. So in order to include function calling in our chatbot, in our conversational chatbot, we have some steps to follow. First, we initialize the history list with the role system and the content. You are a chatbot assistant with specialized tools for answering questions in the field of medicine and law, and you only respond in Arabic. So we want our chatbot to communicate only in Arabic and uses the tools provided for him. Then we select the model. In this case, we are using the LLaMA 3.2 90 billion, and if you want to use any other model, make sure that the model you use has the ability to use external tools. It means the model is pre-trained on function calling and tools usage. Then we start the main loop. We enter a loop where the assistant waits for the user input. If the user types exit, the conversation ends, and each input from the user is added to the history, preserving the conversational context. The model is then called via the API with options like temperature for response creativity and max token for response length. And then to make the conversation more clear, we are choosing the green color for the assistant responses. Now we move to the handling tool calls. If the model identifies need for one of the tools, the code checks if the tool function exists, extract its arguments, call the function, and append the response to the history. Each tool response is printed in blue, indicating that it's a response from a specific tool. The final response, which is the second API call, after using the tool, the assistant generates a final response to continue the conversation, which is printed and added to the history as well. Okay, now let's start testing our AI agent. Let's start by saying hello. Okay, the agent successfully answered us in Arabic and respecting the system message. Let's ask him for something more general. For example, who is Elon Musk? Okay, so now let's test the history capability. My name is Ahmed and I am testing Python code. It answers us in Arabic. Now let's ask him something that I already mentioned and see if he will answer us in Arabic or not. What's my name? Okay, so he even translated my name in Arabic. That's very powerful. Now let's start testing the tool. We will ask him a question that should trigger the tool function related to law. So the question is, what's the difference between the law and why it's important to organize the society? As you can see, the AI agent knew that this question is related to the law topic, so it should call the getLawAnswers tool. It received the answer. This answer here came from the 3 billion model that we have fine-tuned on the law dataset, and then the assistant took this answer and enriched it to provide a complete answer. So this way you will have a complete conversational chatbot with history and tools capability. Let's say exit. So finally, I want to introduce you to suggest three courses. They are all free, so you have no excuses to not doing them on deep learning AI. The first one is function calling and data extraction with LLMs. The second one is functions, tools, and agents with LangChain. And the third one, quantization fundamentals with Hugging Face. I truly recommend these courses if you want to expand your knowledge. So that brings us to the end of today's video. I hope you find it very insightful and you learned something from it. If you really like it, please subscribe and click the like button, and see you in the next video. Bye bye.